Hello. Thank you very much for choosing my talk. I'm here today to talk about version control, tips, tricks, and good citizenship. And this is a new clicker, so I hope it all goes well. So the first thing to say is I wouldn't be here talking and giving this talk to my community without the help of some very special people, one of whom is sat in the front row. Thank you very much, Jenny, because without her giving me a good stern kick in the right place, I wouldn't actually get motivated and get here. So thanks very much for that. For those of you who don't know me, and I'm sure that's most of you, my name's Tess Barnes. I am a multi-language developer, so I spend quite a lot of my day writing PHP, but I also write C#, Delphi, Python, and occasionally JavaScript and CSS for my sins. I'm an agile advocate, which basically means that I like Scrum, I like Kanban, and I won't shut up about it. I work for FastHosts, and they have a really good PHP guild, of which I'm an active member, and that brings some really good, excellent cultural change in our PHP use. This is my first big public conference speech. So I'm going to need some feedback. Whether it's good or bad, it's really, really helpful to develop as a speaker and to make my talks better for you. And if you want to heckle me on Twitter, you can use the heckle track. That's my handle there. I promise I'm not going to reply in the next hour. No, so that's a complete fail. Start that again. Okay, so this talk I'm giving, I came up with the idea of it because I've worked over the years with lots of people that hate version control, and it is the bane of their working life. I would rather, as a developer, be spending my time writing great code to solve complex problems that makes the world a better place. And I am sure that everyone in this room is in it for the same goal. I don't want to spend my time complaining or hearing other people complain about version control and why it's a pain in the backside. So the first thing that I want to do is a bit of a refresher for everyone, which is dealing with text conflicts, dealing with tree conflicts, avoiding conflicts where possible, and sometimes that's not a technological solution, sometimes that's a social solution, and how to deal with some of the more complex code bases that you can end up coming into contact with. Bearing in mind that I'm not sure how the time's going to go, we'll see how many of these extra bonus levels we'll get through. So once we've done the basic stuff, we'll look at keeping it secret, keeping it safe. So how to actually lock down your version control system so only the right people can see it at the right time and interact with it at the correct level that you want. Looking at collaboration and review, clean code and keeping standards. And then if we're really lucky and we haven't run out of time, we'll look at doing change logs for the lazy, keeping everyone in the loop, and how version control can trigger other automated processes in your company depending on what you do. So we'll start first with minor conflicts. They're straightforward. It's not rocket science. They're not scary. So this is the kind of red I'm used to seeing in my ledger. This is a basic TortoiseSVN view. I'm most experienced with SVN. It's very simple. They've done some changes. You've done some changes. You might want to include your changes after their changes. And you merge it. You say it's resolved. All done. So as long as you know your tools, whether you're using SVN or Git or Mercurial, you'll have a command line, you'll have some kind of a GUI interface. As long as you know those, then it's very straightforward. If you know your code base, then it makes it very easy. You know what code changes are going on. You'll recognize how it was before there was changes. And when all else fails, you can always talk to your colleagues. I know this is a radical idea, but there's coffee machines out there. You can have a chat. So the next slightly more complex solution, or slightly more complex situation you might look at, is also a text conflict. I call them interleaving changes. And this is where your diff tool, again, this is TortoiseSVN, but many diff tools work the same way. It will try and help you out, and it will go, I know what that is. That's an opening curly brace. I'm going to hang on to that for dear life. Unfortunately, that means that it can't distinguish between this is not a dummy and this is also not a dummy, because two developers have been replacing the same old method, probably for completely different reasons or for completely different solutions, and you're not quite sure which one should go. You can't just say, take their code and apply it after mine. It's not quite that simple. So we've said that two developers work on the same file at the same time and both replacing the same method. This is blame. These are why I put these in quotes, because these are blame things. Badly scheduled work. Two developers shouldn't be working on the same file at the same time. Yeah, okay. There's no design, so people have been going at it their own sweet way, and there's a lack of communication there. Again, go get coffee. Really helps. So the first question is, which signature do you use? So you've tried to do mine after theirs, but you've still got this dodgy line at the top to sort out. So it's worth taking a step back. And it's worth saying, OK, we'll take their changes. That's absolutely fine. And then to get my changes in, I'll use an underused feature of a diff tool, which is enabling edit. And I will then take my changes out, and I'll just copy and paste them into the merged box. I'll click Save, and I'll click this nice little green tick here, and that says, I'm resolved, I'm sorted, we can just take it as a normal change. And then when you look at your changes before you commit, because everyone checks their modifications before they commit, don't they? This is the sort of thing that you'll be looking at. So that's the really simple stuff. Then we go into slightly different territory, and this is where the fun starts. Anybody seen this face? I've seen this face a lot. It's occasionally in the mirror. So when somebody says, oh, I've got a load of tree conflicts, merges are painful. It shouldn't have to be that painful. So there's three main types. You've got adding a file, and it throws a fit because something's already added that file. Deleting a file, which is going to conflict with someone changing it. And missing files. Missing files is a little bit of an interesting side case, so we'll look at that last. So add conflicts when you're trying to add a file that already has been added by somebody else. So these are cleavers. And so you have your cleaver.php. You've got some properties that you've described, how sharp it is, what it weighs, how long the blade is, and some methods. So this is going to be a class you might use for describing tools that your favorite chefs use. It's a social media site about chefs and recipes and what they recommend as their tools to use them. So yeah, straightforward, fantastic. You try and add it. Now this is the command line version of Subversion, and you'll get this conflict discovered. And you can postpone it, and you say, yeah, great, okay. If you postpone it, you might end up with a text conflict, and it can cope with that, and it should be absolutely fine. You could go as far as saying, okay, I'm going to check what was checked in this area, in this folder, in the last hour or so, just to make sure that somebody hasn't added it before me, before I even go to update or commit. I can postpone, as I've said. I can treat this as a text conflict and say, OK, that's fine. I'm just adding stuff to a file that's already there. I can check the meaning of my file and their file, and I can maybe rename mine. or rename theirs. And I probably want to have a chat with someone if I'm not expecting this ad in this area. I thought I was the only person working in this folder. I might have been mistaken. So we can talk. And technically, you can fix it on your own. You can say, OK, my file needs to go in completely separately to this file. I'm just going to rename my file or rename their file. But should you? And this is where it gets interesting, because these are cleavers. They're meat cleavers. These are also cleavers. This is a Saxon king with his Wittengemot, his followers, his advocates. So they follow his cause. They can be termed as cleavers as well. What if your colleague was writing a class about the followers of the chefs? Then he might have also called that cleavers. It's a medieval world, so it's quite rare, but it's possible. And if you're American, those are also cleavers. Tend to find them on your dog when you've been walking in the fields. So just because your file has the same name as somebody else's doesn't mean the contents are the same, doesn't mean the intent is the same. So this is why we'd always advocate talking to the people that have done the ad and looking a little bit ahead, rather than just going for this simple technical solution all the time. So if you've gone ahead and you've said, OK, this file is clearly not about cleavers, it's about followers, I'm just going to rename this file for this person, I'm going to check in my changes. And depending on who checks in first, someone is going to have a delete conflict. So either you're going to have a deleted file. So this is the person who's had the cleavers file originally and considered followers to be the meaning of it. And they're trying to check in a local edit to it, and there's a delete coming in because your colleague has gone, nah, that should be followers. And here is the other side of it. So you've tried to rename that file, which is an add and a delete. And you've got an incoming edit because they've gone, my cleavers file, I've talked about followers, I probably want a loyalty bonus score in it, something like that. So that's the other side of it. So this is usually the situation. Someone has deleted that nice file you fixed so beautifully. So you spent hours sorting a problem out, and somebody else has just ripped the file out. So it could be just a rename. It could be just that situation. You could solve it via a patch file, so you know what changes you made to your original file. Apply those to the newly named file. It's not that difficult. If it's a massive refactor to that particular file, that particular class, then it's probably worth having a chat to the person who touched it last and collaborate on how you're going to do your changes and do some hand copying. If someone's ripped out a file that you're editing because the entire folder's gone, because product has suddenly decided that they don't want to sell whatever it is you were working on, get a coffee. They've paid for your time. It's not going to be the end of the world. So missing files is a bit of an edge case. It tends to occur when you have feature branches, when you're very feature-focused. So you have a feature branch, you've got your nice stable trunk or master or production, and you are merging code from your stable branch, and then when you've finished, you're merging your feature back down into stable. And because you're merging up from trunk, for instance, you then commit that merge up from trunk into your working branch, into your feature branch. And it's very important to keep that commit separate from anything else you've got going on at the time. So if you've added a file and you hadn't committed it yet and you merged up from trunk and you want to commit, then that add can get hidden. And it not only gets hidden from anyone reading the commit for a code review point of view, it also gets hidden when you start merging about. So you can end up in a situation where you've got an edit that you're trying to merge in, but the original commit of the add is missing. And that's when you're thinking, well, when did it get added? And you start combing through log histories. And I've spent an afternoon sorting this out when one of my colleagues had a family emergency, had to leave the building. So I would say sometimes you might not see this. If you're using Git flow and you have a release strategy in your branching, you might not see this. But I would always say merge up to a clean working copy. It's standard practice. It makes life a lot easier. Using useful commit messages make everything clearer. And when I'm merging back down other people's code because they can't be in the building, I don't have an afternoon of combing through commits and having to pick out specific files. So everything gets a lot easier. So you could ask, why do many people have to deal with so many conflicts? This is why. So at Fastos, there's a lot of developers. In many of the companies that I've worked in, there have been a number of teams working on the same code base. So there's a lot of developers working a lot of the time in overlapping areas. Because of code reviews and live fixing and sprint zero work and other project work that gets snuck in at the last minute, there's a lot of context swapping that goes on. So I do find that swapping between lots of revisions can be quite time consuming. So you can't talk to your colleagues all the time. I know I advocate it, but if we talked all the time when we wanted to, we never actually get any code written, and the boss kind of likes code being written. So yeah, I have to do that. I also see it because there's a move to refactor a lot of legacy code. Moving towards a clean code base is a really, really good idea. It's a great movement with a lot of weight behind it, but it can cause conflicts. So there's a few things to get out of jail free. You've got patch files. Everybody know what a patch file is? I'm seeing some nodding. So that's just a log of the difference between two files you can apply potentially to another file. You've got the option of multiple checkouts, so multiple working copies that you can swap between. I find that very useful when doing code reviews or live bug fixing. In some wonderful IDEs, who's using PHP Storm here? Who uses the stash facility? Excellent, isn't it brilliant? You can stash your work in progress. So in SVN and Git and various other version control systems, you can cherry pick your commits. And in Git, something I've seen with source tree is it's not just on a file basis, it can be on a lines of code basis, which I find very, very powerful. Also helps to have standards that you're working towards and standards that you're enforcing. So PSR2 is code layout. PSR3 is a logging interface. Both of these things work very well to keep your code readable. So everybody gets to get on board very, very quickly. When you first join a company, having a readable code base is one of the key things to getting people up to speed. So why just fix things when they occur? Why just patch things? Why not have a bit of a longer-term strategy? So just talked a little bit about cleaning up your code base. And this is quite a growing movement that's advocated by Matt Cockayne, who started blogging about PHP Code Scouts. And that's the logo there. I personally use the L plate because I don't feel like I've quite got there yet. I'm working towards it. And I think it's better to start working towards it than not start at all. So having clean code is a good starting point. Being prepared, so looking ahead and thinking about what you're about to do rather than just charging in, I find is something that I want to do. Solving root causes, sometimes those are technological. Sometimes those are social, sometimes those are process-driven. And having a strategy for what you want out of your version control system and getting the most out of your chosen tools will go a long way to solving some of those problems. So when it comes to a version control system, I like to think of it as bonsai. It's beautiful, it's well kept, it's cultivated. So you've got principles and branching strategies, and we'll talk a little bit about complexity. So principles of a version control system, it's a tree. It might be a flow, it might be lots of different branches, but effectively it's a tree. And I have a pet peeve, and it's seeing a working copy like this. I think that the point of a version control system is you check out a copy of what you need at the stage you need it. I've seen a lot of people have a checkout like this that end up putting their changed file into the wrong branch. In fact, when I first started, I did it myself. So I think that is really missing the point. So I also say use meaningful names. So if you're going to have a feature, sets of branches or bug fix branches, if you're going to have release branches, make them meaningful, include version numbers, for instance. If you use something like Jira, use a Jira code. Think about how it's going to be released. When it comes to working copies, keeping it clean, as we've already talked about with missing files, is kind of key. You don't want to be messing around with, for instance, with subversion history that isn't quite up to date or doesn't match the files that you've got. Keeping it current is key. If you're going to have feature branches, one of my rules when I work is to merge up from the stable branch every day. So it's the first thing I do. Because that gives me the longest time to go and get a coffee and talk about the changes that have come in overnight or the changes that came in yesterday that are going to conflict with mine. So talking about branching strategy, this very much depends on the kind of products that you're releasing and the way your company is structured, where your products are and who they're being aimed at. So some of the things that I think about for talking about branching strategy is how do components interact? What's common? Are you using common libraries that are developed in-house that are used with multiple components, for instance? How deeply coupled is your infrastructure in that way? How do you do your code reviews? When do you do your code reviews? What do you test? How do you test it? Where do you test it? Does a QA team test it? Do developers test it? What kind of tests do you do? How do you do your releasing? Do you go to a staging environment first? Do you go straight out to production? Do you release every day from your stable master branch because you like to fix things as quickly as possible, as soon as possible, with the most coffee? And what's your apocalypse plan? I knew that was going to be a bad thing when I wrote it. So your hotfix management, how are you going to deal with live problems? So moving on to how to deal with complexity. We've talked about components that work together and share common libraries. And this isn't just third-party libraries that you might load with Composer. These are things that are developed in-house that might have changes alongside what you're actually working on. And I'm really lazy. If I can get away with doing the minimum work, I will. So I don't want to spend my time checking out 4 different locations across 2 version control repositories by hand. I tend to go for the one script to rule them all because it's lazy. It's great. I can handle complex project checkouts with it. So if there's various dependent components and they're spread across 4 folders, I can do it in one command line. I miss things less when I'm checking in, so my favorite habit is to miss adding. But if I've actually run a check modifications or get status on all of the folders simultaneously using one script, I'm going to say, hang on, there's something missing there. And it's a way of looking ahead before updating. So I can actually look at what's already in the log and look at what changes I've got before I start doing any updating or committing. I will say there is a caveat to this. I don't ever commit by script. I commit by hand. So I'll look at things in a folder and I'll make sure that I can do that because I want the flexibility of being able to choose my individual commits and cherry pick and maybe commit a selection of files as one commit and then additional files as a second commit because I like to keep the intent quite small and well defined. So this is an example. You could wrap this in a bash script, in shell script, anything that will run on the command line. This is SVN specific, but Git has a command line, so there's no reason why you couldn't do the equivalent. So on checkout, we've just got the checkout, particular repository, components, and your dependent components. And these locations can be separate locations. So I have worked on projects in the past that are across 3 repositories because they're using shared components that are developed by different teams who all like their own flavor of a repository. So I don't want to see this face again. I'm trying not to see it in my mirror too often. I like it when I can see that face. So that's the basics. Okay? So now we're into bonus levels. Getting more out of your version control, to me, is quite exciting. It isn't so much just one technology, it's what else it can drive. And what it can drive is limited only by your imagination. So we've talked about what we might cover: keeping it secret, keeping it safe, collaboration and review, keeping clean codes, enforcing standards, and some things that we can run after the commit. So these rely on hooks. SVN and Git, certainly, potentially other version control systems I haven't used also have this. Who knows what a hook is? Who's set up something that uses a hook? Excellent. So, as a quick summary, I see a hook as an insertion point. It's a pause in the commit process where you can put your own custom code. You can put it at various stages, and depending on what version control system you use, those stages differ slightly. But basically, it's something that happens before you get to the commit and something that you can trigger off after your commit has happened. There's server-side flavors and client-side flavors available, and they have their own pluses and minuses. And it is slightly different depending on whether you're on a centralized system like SVN or what I call a pseudo-distributed system, so Git that's run from a server. So it's not truly distributed like you could use Git, but it's got a server element to it. So these are the few things, or some of the things that you can do on the first types of hooks. So enforcing authorization on your start commit hook, enforcing your code review or your standards on your pre-commit hook, and part of the joy of creating your changelogs easily also sits on your pre-commit hook. So is it secret? Is it safe? You might want to have authorization on your version control system. Your company may enforce it. Your systems guys may say, you've got to have it because I'm not having my server hacked. And it basically comes down to a few simple questions. Do you want the world to be able to read everything? Are you on a public repository on GitHub? Do you want everybody to be able to fork your code? That's great. If it's open source, brilliant. But you might have some more sensitive components. You might have proprietary code that your company doesn't want everyone to be able to read or to check out. The other reason why authorization can be important is that only certain people might be allowed to commit to a particular branch or set of branches because of the sensitivity of the component, because of trust within a certain team or a certain level of developer within a team, or just because you want to make sure that the code is checked before it's checked in. And one of the questions that might be asked if you're talking about authorization is, how often does this change? Because maintaining authorization can be a bit of a manual task. And if you want to change it every 5 minutes because you have people hopping in and out of roles in your developer teams, then you might want to get whoever it is that authorizes this some more cookies. So there's very traditional solutions for SVN. Apache and SVN Serve both have an authorization module and a rules file that's associated with it. Both of them support LDAP, so it's a fairly standard authorization system. You have a username and password. You log. It gives you certain roles and responsibilities within the version control repository on the server where it sits and allows you to do certain things. If you use Git, who uses Git? Pretty much everyone. Excellent. So GitLab have a cloud enterprise or community edition for Linux. And if you go self-serve, they have LDAP options. Bitbucket, again, it's proprietary commercial license, enterprise edition. They do an academic license, which you have to register for a specific organization, but it's their equivalent, the community license. And again, they've got LDAP on that. So that's kind of authorization. Enforcing code review, because 2 heads are better than 1, unless you happen to be this guy. So many people have a very traditional view of code reviews. It's just a case of looking in the log and making sure it's all okay. But using tools can help with that and make it a lot easier to handle by getting a window into the code. So you don't have to check out the code to be able to read about it or to review it. It means that visibility of reviews could be out to everyone. Not every team has the resources or space to go and sit in a room and show code on a projector like this and discuss it. Some teams work really well like that, and other teams find it not so possible. So the option of having multiple reviewers when you're all checking out your working copy is not necessarily practical. You can also use tools for code review that protect your master repository. So if you're using Git, you have a code review stage, and it won't let anything through pull request, push request, until it's gone through its process. So you could roll your own. You could have a database that is populated by scraping all of the revisions from your commit log, and it could have a tally against it, the number of people that said they've code reviewed it, and only when all of the information is in the database, you check that when you're doing your pull request or your push request, and Bob's your uncle, you can go in and that's fine. But that seems very laborious. There's a lot of other options. So you can enforce a code review by saying only certain people can merge down into your stable branch. And those people are going to code review what they're about to commit. You could automate the basics. So if you write Python or C#, you can actually compile the code, make sure it builds before it goes into your version control. PHP world, I think the nearest we have is the lint and the fatal options on that. So that has disadvantages in that it'll only do a file at a time, and it will stop when it finds the first error. So it's not ideal. If you use an IDE or get decent plugins, then you get quite a lot for free. So you'll get your syntax checkers and so on in that. So It's probably better to get built-in tools for this if you want to use an automated way of handling it. If you've got something like GitLab, Bitbucket, Gitflow, GitLab Flow, GitHub, you're sensing a theme here, they'll handle merge requests and pull requests. So that will automatically suggest that whoever sees that pull request will be able to review the code before they'll accept it in. There's also gateway software out on the market. I say market. Gerrit is an open source, free Java-based tool, and it sits between your working copy. It actually sits on the server before you get to your Git master or production. So it'll accept a pull request to a point, and then it has its own process for saying this code has been committed. And lots of people can log in, look at that code, mark it as, yep, that's absolutely fine, or put comments on it and say, no, that's rubbish, get rid of it, go rewrite it. And when everybody's happy and the rules you've set up in Gerrit are satisfied, your code can then go into master or production. So that's 2 down. We've definitely got time for at least another one. Enforcing standards, I think, is actually a really good idea. It's something that we've been discussing for quite a while. And it makes it easier to handle when you're looking for that one missing semicolon. It won't necessarily find it for you, but it will make life a lot easier. So PHP world, there's PHP Code Sniffer. It's pretty much well known. C#, we use stylecop. Python, I'll compile the file, though, before I'll commit it. So you can enforce standards in a number of ways. You can have it on the client side as a pre-commit hook. For Git, that's pretty much your choice, effectively, because you have a distributed repository. It's all going to be client side. You can have a server-side hook, and I'll come back to that. You can refuse the commit then when the changes don't pass. So for instance, PHP Code Sniffer has an output that says, I've got a lot of warnings and I've got 3 errors. And you can say, forget it. If there's an error, you don't get in through the door. You could say, for a live fix that has to go out now, I'm not going to worry that my code layout does not meet PSR2 this time. So you could give grace with a threshold. You could say, it's a legacy code base, we're in the process of transitioning it, we can have a little bit of leeway. So SVN again, because that's where my experience lies. This is a client-side version of it. So you would set up your hook script. Wrong button. You'd set up your hook script here, and your hook script would have the command line that calls a bigger script. So you actually fire off your code sniffer on your own machine. So you check your current directory, the whole directory, or you might just check the files that you've changed. It's not great. Each developer is in control of their environment, and if they're anything like me, they like customizing it quite a lot. So they're in control, and you can't always guarantee that these will run or that they won't in some way be changed or skipped. So you could use a server-side example. That's not as easy in Git, so you tend to get it at the pull request stage. This in SVN will simply run your code sniffer, and PSR2 is standard you can import on that, your repo, which is where you're committing to, your text, which is what you're trying to commit. And you can actually go into PHP Code Sniffer. I haven't chatted to them about this, but you should say, okay, you can add a tolerance and say if the number of errors is above the tolerance, then forget it, they're not getting in. But you can allow a little bit of leeway if you're in a transition phase. So that's mostly the things that you're going to be doing on pre-commit or thinking about when you're doing pull requests. I hate writing documentation. Even if it's just a list of changes I'm passing to my wonderful colleagues who do quality assurance, and I don't like doing it. I'm just lazy. So I like to do things in a slightly more automated way, and I really enjoyed researching this because it's something I think that could really help. So on the pre-commit, you'd enforce commit message patterns. And I know some people hate this because if you're doing a ridiculously fast fix and it needs to go out on Friday at 5 p.m. because you don't want your site to be broken over the weekend, fair enough. Stick a hotfix tag in it. I don't care. That's fine. So enforcing message patterns actually makes things for code review and for merging code down into trunk when your colleague's gone out of the building much, much easier. It encourages user-facing comments, and sometimes that user could be your QA engineer, not necessarily the general public. And then in post-commit, and this is the first post-commit hook that I've talked about, you can scrape the log. You can convert it and make it publishable. You can allow the hotfix tag that I've just talked about to be treated completely differently. So you could exclude those commits from a changelog or put them as a separate list. You could allow merging up from trunk and merging of third-party software also to be treated differently. And most importantly, when you're working with multiple repositories that all feed components into the same product, you can combine logs from multiple sources. And this isn't your Elk stack combining application logs. This is a way of getting your change logs in a format that somebody can read, update, publish. So this is a fairly standard example commit message check. This one's SVN. There are Git obviously, that are available. If you're running this sort of thing on Git, one of the gotchas that I came across is that when you check out the repository and clone your own copy, you don't get these by default. Does everybody know that? Okay, good. Just me then. Every day's a learning day. So you can check for minimum length in this way and pattern matching. You can allow for particular special tags that relate to third parties. So here, for instance, that is a regex that matches up with a JIRA ticket number. That will match up with a no JIRA. I haven't got JIRA for this, it's a hotfix, go away. And this particular example that I found on Grimsby's blog had Maven release plugin, so third-party code. So on your post-commit, or by a cron job or some kind of automated regular process, you could scrape the details. Now, this is Python script that I just knocked up. So this runs an output of the command line and puts it in a variable. It uses a nice little module that Python's got, which is XML to dictionary. So this SVN log XML option makes it machine readable, so it's just easily parsable. The human readable is really good if you're going to look at it at screen, but it's not so useful for doing data analysis with. So you can check out a different repro, and you can add your additional data in there and extract it, rip out the ones that you don't want. So I've just gone through. That range is effectively a reverse for loop. So it'll go through things in reverse order. And And you end up with, at the end of this, a dictionary of the entries that you want to work with. Now, you could do anything with that. You could only add the latest ones. You can FTP it somewhere. You could push these entries onto a message queue. And you can do email notification. Now, I'm running short of time, so I'm going to skip over the next couple of slides really, really quickly. So this slide is about keeping everything in the loop. So everyone can be notified when they want to be notified. So we can avoid duplication. We can keep it relevant. We can make sure that you don't get notifications for every single commit ever, because you won't read them. And if you're like me, they'll filter straight into the bin. Rubbish. So there's a number of options of ways that you can notify people there. And if you want to know more about them, you can always catch up with me after the talk. You can also start a revolution. So your post-commit hook can talk to Jenkins API or Bamboo API or Rundeck API. Be aware that the server load on Jenkins, or Jira for that matter on notifications, has to be taken into account. I've heard of Jira servers being turned off because their API use took down the server. So always worth having a communication with the rest of your team and the wider business. So it's fairly obvious the things that you can do to set that off. So I would urge everyone, I'm urging myself as well, to get comfortable with the basics again. Always make sure that stays in your head. Talk to each other. It's not just technical solutions that can solve these problems. Care about your code. I hope everyone here cares about their code and is passionate about it as I am. And consider how version control can fit in and get the most out of it. Don't panic. These slides will be up on Speaker Deck after the talk, and there's a number of slides about the extra topics and extra information that you can look at. My slides are Creative Commons license, and all of the images in there and all the content in there, I tried to credit as much as I can. If you spot anything that you think needs to be referenced in a different way, please do let me know. Thank you very much for listening. Please give me feedback. You've been a fabulous audience, and I'd really like to hear the good sides and the bad sides, what I could do better next time. Are there any questions? Great, I'm Scarpa.
Hi. I'm just wondering, does Fasthost use SVN as their chosen version control system, or is that your preference?
I have, in my career, the most experience with SVN. It's certainly not the only thing that Fasthost has used.
Okay, I'm probably going to start a flame war or something, but what are your reasons for choosing SVN over Git?
My reasons for choosing SVN over the Git, probably just experience. It isn't that I have chosen SVN over Git, it's just that I've spent more years using it. I first started using version control when I was freelancing, basically to help myself because I coded myself into a hole. I spent a day coding myself out of a hole. I never wanted to do that again. So version was just the first thing I came across.
Okay.
So it's just history. It's not feature specific.
Sorry to carry on, but I feel like if you use Git instead of SVN, it probably would have solved a lot of your problems with merging and the branches because it uses a different kind of structure.
Absolutely. I think Git has a lot of advantages. This talk is really for people that still feel like they can't ask all of the questions. So for instance, when you first join a company, if you come into contact with a version control system that either you haven't used before or you haven't used in the way that the company's using it, then sometimes I feel, it's not rocket science. I shouldn't be able to ask a question about it. I'll look really stupid. And I wouldn't want anyone to feel like that I work with. So.
Fair answers, thank you.
Good questions. In front?
What's your Twitter handle?
What's my Twitter handle? Oh, this means I've got to go right back to the start. Yeah, it's just interesting to spell. Oh, there should be a shortcut in this. I'm sure there is. That's my homework.
CRATAEGUSE. I'm not finished yet. TESS. There you go.
Okay.
Complete for the win, by the way.
I think that should stay up there now. If there's no other questions, thank you very much for being a very attentive and wonderful audience, and thank you.